All right? Or I have 1 mole of carbon in 1 mole of that. Now that sometimes bothers people because, for example, if I have a chemical reaction here, A2B3, and this decomposes, and I have now 2 A's and 3 B's, over here I have 1 mole of this thing, and it decomposes into now 5 moles of stuff. All right? And at some point, some people will say there's something wrong there. That doesn't make any sense. But if you think about it as maybe a hamburger, right? If I take a hamburger and break it down into its parts, I'll have 1 patty and 2 buns. Right? I started off with how many hamburgers? 1. And now I have 1 patty and 2 buns. Right? So I had 1 thing and now I have 3. That's not hard to understand what's going on there. Right? If I had 1 dozen of these, I would have 1 dozen of patties and 2 dozens of buns, right? So it's the same scenario here. It's not a conservation, it's not against the law of conservation to say I have 1 mole of material here and 5 moles of material over here. Okay? For the same reason. So when I make statements like in every mole of sodium carbonate, I get 1 mole of 2 moles of sodium, that's a stoichiometric statement, right? I'm talking about the stoichiometry. You can also make that statement in this sort of a reaction. If I have 1 mole of this material and it decomposes, I'll get 2 moles of A, right? Or another one is, how many moles of ions do I have if I have 1 mole of this compound? What's the name of this compound here? Sodium phosphate. How many moles of ions are there in here? If I have 1 mole of sodium phosphate, how many moles of ions? What are the different kinds of ions? Sodium ions and what's the charge on the phosphate? PO4 3 minus, all right. So those are the kinds of ions. 1 mole of this will result in how many sodiums? 3. Good. So how many moles of ions do I have if I have 1 mole of sodium phosphate? 1, 2, 3, 4. Right? 4 moles of ions for every mole of sodium phosphate. Okay? Different kinds of stoichiometric statements that can be made. So, can you calculate the number of moles of sodium if I have 2.53 moles of sodium carbonate? You can't? Sure you can. Use the method. Put an equal sign, draw a line, use the units that you're after to the right of the equal sign. And again, even if you know what to do here, this is really all about helping us recognize the method. So we get plenty of easy problems to use this method. So I'm going to come around and see if I can see the equal sign on your paper with the line, with the units that we're after on the left. Are you stuck, or you know what to do after that? You're stuck? Okay. Well, here's one problem. You got to say moles of what? What is it? Sodium carbonate, right? 2.53 moles of sodium carbonate. Do you remember what sodium carbonate looks like? There it is, Na2CO3. So then what units have to go down here? Yeah, moles of sodium carbonate, right? So what units want do you want to have up here?
Sodium.
Moles of sodium. Moles of sodium. Right? So do you know how many moles of sodium are in a mole of sodium carbonate?
Not really.
No? Remember this? There's 2 moles of sodium for every 1 mole of sodium carbonate. Does that make sense to you, that statement, or not really? Okay, so if I have, let's look here. If I have 1 unit of this material, within that unit, it's like 1 hamburger. Within that hamburger, there's 2 buns and 1 patty. So for every hamburger that I have, if I have a mole of them, I'm going to have 2 moles of sodium. So the stoichiometric relationship here is there's 2 moles of sodium for every mole of that stuff. Okay. Hey, why don't you get a roll there? Sign it. There you go. Why don't you sign it and hand it out to them? Okay, so I saw some really beautiful stuff out there. Lots of this. Lots of this. Moles of sodium. 2.53 moles of Na2CO3. That's where I hope you can get without using any brain cells. Who feels like they can get to this point without using brain cells? Raise your hand if you feel like you can know what's going on to get to this point. Anybody feel like they can't get to this point because we haven't talked about it enough? Okay. Now, I did see some of this. 2.3 moles. Or some of this. Moles. The problem here is what? Yeah, it's a map with lines that are roads, but I don't have the names of the roads, right? So I need a map here that's helping me. This is my goal, so I need to make sure I clearly state my goal, moles of sodium. And this one, it's very critical that I know what chemical I'm starting with, right? All right. That point should be free of brain cells, right? We'll use 2.5 brain cells to find out the units here. What are the units here? Moles of sodium carbonate, Na2CO3. How did I know that? Simply because this is what I need to get rid of, right? All right. Now, a handful more brain cells to find out what I would like up here. What would I like up here? Moles of sodium. Now, do I know a relationship of the moles of sodium to moles of sodium carbonate? Okay, I do, because we just talked about it. But if you don't, then you erase it, or you start over, it's okay, and then know that moles of sodium have to go over here. But for us, we should hopefully be able to recognize that, and this, some people couldn't quite get it. So I see another option for you is cross that out temporarily, and instead of putting moles, put what? What's that? What did I say we can replace moles with when it's confusing or too much for our brain? Dozen. Very good. Sorry about that. Didn't hear you. Dozen. So if I have a dozen of these, that means I have how many of these? 2 dozen, right? Because for every one of these, there's 2 of these for each one, right? Okay, and now I can cross that out and just really use moles. It works the same though, right? If you're going from dozens to dozens. Okay, so then that should be my answer, right? Because I'm in moles of sodium. All right?
You then cross off
Oh, this is not right? There we go. Moles of sodium, 2 moles of sodium for every 1 mole of sodium carbonate. Okay? This is like my hamburger, right? 2 buns, the 2 sodiums, and 1 carbonate, 1 patty. Great. Okay, how about this one? Can we calculate the number of atoms of sodium in 2.53 moles of sodium carbonate? We could hijack this one and go from moles to atoms, but for practice, we'll start over with an equal sign and a line. Start trying to fill it out for yourself. What goes to the right of the equal sign? Atoms of sodium, right? Did everybody get the roll? All right. Does that say atoms of sodium? Wonderful. And this says moles of sodium carbonate? Yeah. Perfect. What has to go down here? That's right. Very good. So, atoms of sodium, 2.53 moles of sodium carbonate. And I know that moles of sodium carbonate are going to go there. Who got this far? Raise your hand if you got that far. Excellent. Any ideas on where to go from here? Where? Moles of sodium. All right. Now look. If we're not sure that that's right, there's no harm in going there and then turning around and coming back a different time, right? It's okay. Nothing dangerous in chemistry. That's nice. So let's just go there for a second and see what that can do for us. If we do have that there, I told you about where we're at when we go to this spot. Where are we at? Remember I told you there's a magical land? The land of the moles, right? And really what we're after in the land of the moles is the power of the stoichiometry. The power of the stoichiometry. So here in the land of the moles, we'll get the power of the stoichiometry. We'll do that in a bit. What goes down here, though? Moles of sodium again. Very good. Now, we'd like to have atoms of sodium. Is there a relationship between the number of atoms of sodium and moles of sodium? Yes, there is. Just like if this was a dozen, this would be 12. If it's a mole, it's 6.02 times 10 to the 23rd. Huge number, right? That's how many atoms there are in a mole of atoms. That's also how many dogs there are in a mole of dogs. Somebody should find out if there was a mole of dogs on the Earth, how big the Earth would be. Have to be bigger than the solar system. Might even be bigger than the entire known galaxy. Who knows? But it'd be huge. Okay, so 1 mole of sodium, 6.02 times 10 to the 23rd. What's our relationship here? Yeah, 2 moles of sodium for every 1 mole of sodium carbonate. Excellent. Anybody get an answer in your calculator? The time has come, my friends. I gave you some warnings about calculators, and now we're in the thick of it. Because if you don't have the ability to write these types of numbers in your calculators because of practice or whatever, then you'll start getting behind. So, if you don't have a calculator, it's time to do what? Go get one. Go get one. Go get a good one. If you don't know how to write this and you want to have help, I can help you if you have the kind of calculator I'm familiar with. Or you can go online. YouTube has lots of people that get money for every time you click on them, if you ask them the right question. Okay, 3.05 times 10 to the 24th. Did anybody get their calculator to spit that value out? Okay, so we got 3 or 4 people getting it. Good. Everybody else is kind of like, I know I could do that, right? I know I can do that, right? Or nobody raised their hand. Are we getting it? Is that okay? Yeah. Okay. Should we try one here then? Okay, good. Why don't you consult your neighbor? I'll go outside and let you guys talk freely. I know you're so shy. And I'll be right back, okay? All right, equal sign. Should I come around and see how you're doing first? How are you guys doing? Didn't get anything, huh? Is it because your neighbor? Is it his fault? All right, what goes to the right of the equal sign? Any ideas?
Iron. Right?
Specifically, atoms of iron. Atoms of iron. Fe. Fe is iron. What in the world's iron 3 oxide? Fe, an O, 2, and a 3? Does it matter? Could I just put in there FeO and find out how we get there? No, it does matter, doesn't it? Because in the land of the moles, we're going to get that stoichiometry. We got to get the right one. So, critical to know what the compound is. That's it. Iron 3 oxide. All right. Grams of Fe2O3 go down here, right? What goes up here? Where am I going? Land of the moles. Moles of Fe2O3. Then, once I have moles of Fe2O3, what am I going to do with that? First, I need to go to moles of iron, right? Moles of iron. And then after I have moles of iron, I can go to atoms of iron. All right, maybe talk with your neighbor. Make sure you know the values that go into these conversion factors. So are you my neighbor?
Yes.
How does that work? Are you guys, is that your family there?
Yeah.
Oh, I didn't know that. That's cool. I saw you guys over there. I was like, wait a second.
Yeah, I talked to your son. He looks exactly like your son.
That's hilarious. So, how long have you guys lived there?
We lived there for like a year now.
Oh, really?
Yeah, we lived on Giuseppe in Policano.
Ah.
But now we're on the wall.
So you just moved there, huh?
A little bit ago, so probably like almost a year ago.
Yeah, but not terribly long. Huh? So what do your folks do, or how do they do?
Economics.
Economics, okay. Cool. That's awesome. Yeah, I haven't ever really seen you very close. I've just seen your cast or your one of it. That's gotta be her. It's so far away, but it's gotta be hers. That's cool. All right, so then, what are the values that go, which one's easy? Well, I don't know, this one's easy right here, right? What is it right here? 2 to 1. 2 moles of iron for every mole of iron oxide, iron 3 oxide. How about here? What values go here? 1 mole, 159.7 about? Very good. What about here? What goes here? 1 mole, 6.02 times 10 to the 23rd. Right? Wonderful. Okay, did anybody get an answer that's on the board? Which one is it? A? Beautiful. Okay. Should we do another one of those, or do you think you got it? One more? Okay. How many moles of ions, moles of ions. No. How many ions, that, are in 7.3 grams of calcium, phosphate. There we go. How many ions are in 7.3 grams of calcium phosphate? Oh. Did you know you can ask your phone molar masses? What's the molar mass of calcium phosphate?
Tricalcium phosphate has a molar mass of 310.18 grams per mole.
18 grams per mole. So that's helpful. If I didn't have my phone with me, what could I do? Add up the numbers of the things, correct? It's still critical that I know the chemical formula of calcium phosphate, right? Okay, what goes to the right of the equal sign? Yeah, we're looking for the number of ions. Right, the number of ions. How about the top left? Start with maybe? 7.3 grams. What's the chemical formula for calcium phosphate? Ca 3 PO4 2. All right, good. And then must be grams of calcium phosphate down here. Where am I going to go? Moles. Moles of calcium phosphate. Why do we go to the land of the moles all the time? I'm going to ask you that a lot over the year, the class. Why do we always go to the land of the moles? And you're going to say, because in the land of the moles is the power of the stoichiometry, right? And we have to go get it. So you're going to say the power of the stoichiometry, or the power of the equation. In this case, it's just stoichiometry. All right. After I get moles of calcium phosphate, what's next? What am I after? I'm trying to get to number of ions. If this was number of atoms, where would we go next? For number, we would go like moles of whatever atoms we were after, moles of iron, like we did over there, or moles of calcium, right? So instead, we want to go to moles of what? Ions, moles of ions. How many moles of ions are there in a mole of calcium phosphate? 5. 5 moles of ions. Let me write that out clearly. Ca2, or no, 3, Ca3, PO4, 2. So you can see we have 3 calcium ions and 2 phosphate ions. That's 5 moles, right, of ions. Okay, very good. So 1 mole of calcium phosphate, 5 moles of ions. And then I can go from moles of ions to number of ions. What's here? What goes here? If this is a dozen, that would be what? 12, right? But because it's a mole, this is our 6.02 times 10 to the 23rd. Okay, anybody get an answer here? Anybody else get it? Okay, one other person did. Okay, very good. I don't know, I feel like we're going to have trouble when we're asked to do this in the future. You think? Maybe we should practice some outside of class when we're not so tired. Okay, sounds good. Another important principle that becomes valuable to us in the future is the idea of percent composition of a chemical. Now, when we say percent composition, if I look at Na2CO3, I might be tempted to say I have 2 sodiums, 1 carbon, and 3 oxygen. Right? And so that's 6 altogether, so half of that is oxygen. Can you see that? But that's not how we do it. We don't do it in terms of moles. We do it when we talk about percentage of material, we calculate it in terms of mass. Mass. So, 1 mole of that weighs, any ideas? Here it is. Don't worry, I got it. What's the molar mass of sodium carbonate? It's like 106.
Sodium carbonate has a molar mass of 105.9888 grams per mole.
Okay, so that's 106 grams for all of these things added up together, right? So what mass of this 106 is from the sodium? How much does sodium weigh? About 23, 22.9, something like that. So there's 2 sodiums, that's 23 plus 23, 46. And if I divide that by my 106, that should be my, well, times by 100, sorry. That should be my what? My percent sodium, right? My 44.38 or 43.38 percentage of sodium. You see how we did that? Okay, and obviously the percentages should add up to 100%, right? For all the different elements. Let's see if you can do that one. What percentage of carbon dioxide is actually carbon? Can you do that one? And again, it's not mass or not mole percentage, but it's mass percentage, so. What's the percentage of carbon in carbon dioxide? How much is a unit of carbon dioxide? Anybody know? Anybody done the work so that we can all cheat off of them? Does it say right there for us? Oh, carbon's 12, oxygen's 16. 44 grams per mole. That's nice, thank you. 44 grams per mole. So how do we determine percentage of carbon and all that? What mass is due to carbon? Is it 12? Is that how much mass of carbon is? All right, so 12 divided by 44 times 100, that should give it to us, right? What do you guys get? All right, great. Let's figure out if we're right or not. And the rest should be oxygen, right? Good. So 100% minus the 27.3 would be oxygen in terms of mass percentage. Is everybody okay with that? Any questions on that? All right, great. How about this? We have a sample that contains nitrogen and oxygen. These are the masses of nitrogen and oxygen in that sample. Can we identify what the percentage of nitrogen and the percentage of oxygen is for a given sample? Can you do that one? What's the percentage of nitrogen and oxygen? Well, we have some sample. Apparently, the mass of that sample is 0.1417 plus 0.4045, right? That's the total mass. Right, yeah, because that's all there is, I guess. I saw the night show the other night. I didn't know you danced in the night show. Good job. Oh, you don't dance in the night show? That's what you should tell people. I don't dance in the night show. Okay, we add them together. That'll be our total mass. So what do we got to do here? We got to add them together. And if we want to find percent nitrogen, we take our mass of nitrogen over the total, right? Very good. Who got that one? Raise your hand if you got that one. Okay, good. How about this kind of a question? Do you remember this kind of a question from math? If there's 35.5 questions on the test and I got 23.5% right, how many questions did I get right? You know how to answer that sort of thing? $35.5 grams total. 23.5% is silicon. If it was 100% silicon, 35.5 grams of it would be silicon, right? If it was 50% silicon, you take the 35.5, multiply it by 0.5, right? So in this case, 35.5 times the 0.235, that'll give us our mass of silicon. You guys remember that business? That was a long time ago, math. Never did this sort of thing before? Must have. Oh, I thought you said no.
Oh, sorry, no, I was doing my thing.
Okay. Okay? Anybody want to go over this one any further? This is just a little recall question. Anybody want to talk about this one anymore? So you mean like, well, how did you set it up? x over 35.5, like that, equals 23.5 out of 100. Is that what you did? Yeah, that works. Good. So you're saying basically if I had a 100-gram sample, then 23.5 grams would be silicon. And I have 35.5 gram sample. Okay, good. Excellent. I think we're going to stop for today. Is that okay? I think we need to find a way to get more energy in the class. Now, it would help if you guys went to bed on time. I'll bet you anything you guys are all going to bed after 11 o'clock. Yeah. Maybe not, because not everybody's tired. But let's see, what else can we do to... I was just thinking the other day, we used to have this, well, I decided not to use it. We'll see. Maybe I'll come up with other stuff to do. But, yeah, if we get into this right here, I don't think that you guys will remember it next time. So, okay? We'll come back again on Friday.